are in listen-only mode.
Hey everybody, welcome back to Young Engineers of Today. As always, um, hope you guys are having a good week so far. Hope everything's interesting. You know, the usual things that I hope for you guys. Because, things have got to be interesting. Things have got to stay interesting, but in a good way. It's good to have boring times in your life every once in a while, but got to keep the adventure in life. Which is, it's high school. I know there's a lot of structure to it, but if it was anything like my high school, there's probably a lot of interesting things in day-to-day life anyway. But that's enough of me getting sidetracked. We're going to continue with Godot. And we're actually going to make the project work this time, unlike the last time when I had my silly little issue. As these things tend to happen, about 5 minutes after the class, I figured out exactly what I was doing wrong, and I feel very, 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 very silly now. But I learned a little something in addition. So now I know that for the future. And it'll be a good thing for you guys to know as well. So let me go ahead and get Godot open, and then I'll spend some time explaining what exactly went wonky. So I'm getting it open right now. And just as proof, let me go ahead and start it up real quick. Notice that the ball is moving at a much more reasonable speed. In addition, bounces off the paddle exactly where it's supposed to. It bounces out the bottom exactly where it's supposed to, and it respawns exactly where it's supposed to. And of course it's going to get stuck like this because we didn't actually implement movement to the paddles yet, which we're going to do today. But everything is all of a sudden a reasonable size. Well, what exactly changed? Well, you remember how I was saying that the grid was all weird and stretched on my screen? Like the vertical part of the grid was normal, but then the horizontal part of the grid was stretched out all funky. And now I had to do all of that sort of random stuff like if ball position dot y is greater than 32 or less than negative 32 and blah, blah, blah. Well, allow me to put it this way. The viewport represents what's visible in the game, right? This represents the window that we play with, or play in, rather, when we play our game. Something I didn't realize about Godot's engine is that viewport is, you can think of it like an invisible node. That invisible node is going to be a child of the base node in the scene. What do I mean by that? Well, what's the base node in this scene? Exactly, node 2D. Node 2D is the base node in our scene. That's what everything else is a child of in our game. The ball is a child of node 2D. The center line is a child of node 2D. The right and left paddles are children of node 2D. But there are a number of invisible ones as well. Now, you'll also notice that my node 2D is currently selected, like I have it clicked on, and you'll see it's right here. It's kind of hanging out at the origin, and it's a lot smaller. Now let me show you something that happens when I move the node 2D. You see that? All of the children are moving as well. Now let me show you what happens if I resize node 2D. The children are resizing as well. So basically, originally, I had you guys set up their node 2D so it was like that, right? So what was happening to the view screen and everything in it? It got moved. Yeah, exactly. It got moved, it got stretched, it got squashed. Um, it basically just got wholly unrecognizable from the original view screen size and location. So everything was messed up, basically. And that was simply because I had the bright idea of moving the node 2D, which is not something I'd done originally when I first made this. I didn't even try to do that. I just sort of set everything else up, and I thought this time around maybe might be anyway. I was wrong. That's the thing about coding. It will make you feel like the smartest person alive, and it'll also make you feel like the dumbest person alive. It just depends on how things go. So, in my defense, it's not exactly explained in the documentation that that happens, but I should have known better. So that was a moment where I felt like the dumbest person alive. Upshot of it is, we now know how to fix your guys' games and just get them up to operating condition, no problem at all. So what I'm going to do is I'm going to have you select node 2D in your scene view, because we are going to fix your games. So now that you've got it selected over here, you might notice that you've got all this information in the inspector: transform, visibility, material, blah, 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 including the script. Here's what I want you to do. I want you under position to set the X and the Y both to 0. Just type in 0 and make sure to hit enter for each one. Otherwise it doesn't update. See, if I type like 10 and then I click away from it, it didn't update. But if I type 10 and hit enter, then it updates. So you want to make sure that it's at 0, 0, and just hit enter in each of these fields after you've entered in a 0. That will place our node 2D back at the origin, which will move the 0, 0 of our view screen to the origin again like it should be. Next, under scale, you're going to want to make sure that the X and the Y are both 1. Just 1. If you prefer, you can type 1.0, but the important thing is that they are 1 exactly. Why do you think we want the scale to be like 1 instead of 0? Or 2 or 8 or 9 or 5 or whatever? Exactly. Yeah, so it's a box and not nothing. The scale is a multiplier. There is a base size set in all of our stuff in Godot, including node 2D, and then that base size gets multiplied by the scale. So the X will get multiplied by 1, or whatever number's in here, and the y will get multiplied by whatever number's in here. If we keep them both at 1, then it is the original size of the node 2D. By extension, it's going to be the size we want for the view screen, and it's going to be the size we want for everything inside of it. So once you've done that, you're probably going to notice that your entire game has been moved up inside of Node 2D. Probably, I would imagine. Now, that process is going to be a little bit annoying, but basically it's just going to involve you dragging that stuff out into the view screen, keeping Node 2D up here. If you want to, you can lock Node 2D in place. You can click on it and then click the anchor or the lock up here, and that will ensure that you can't accidentally move it anywhere, and select Node 2D, which is exactly what we're trying to avoid right now. We want to keep Node 2D there exactly as it is with a 1-to-1 scale at the origin. That would be perfect. What we want to do is we want to move all of the children out into the view screen so it looks like this. So I'll give you guys like a couple of minutes to do that. I guess just raise your hand once you're satisfied with like the positioning of everything. I'm gonna fine-tune mine a little bit too. Make the paddles a little bit bigger. The scales for the paddle and the ball. The ball, I've got tiny, tiny, tiny. So let's do 0.3. No. Let's do 0.7. So for the ball, I've got 0.7 by 0.7. That's its scale. So it's smaller than the ball traditionally would be. And then for the paddles, I have it be 0.6 by 0.6 on both of them. So the ball is 0.7, 0.7, and the scale or the paddles are 0.6, 0.6. So yeah, again, just raise your hand once you've gotten everything back into a position that you are happy with. And if it makes your life any easier, this tool up here, the Move Node tool, you can click that one and then select a node, and you're guaranteed to just move the node around instead of resizing it or accidentally selecting something else. Because I know that's sometimes a thing that I deal with. All right, we got one hand up so far, out of 5 possible. So we'll give it a few more minutes. 2 hands. 3 hands. 4. Okay, so now that we've got that done, right? We need to go in and fix the values in the code, the script, that I fussed around with because I was barking up the wrong tree as far as the solution is concerned. So I went ahead and did that after I'd figured out the issue that I had. And so I'm just going to copy paste the code into the chat box so that you can do the same. And that saves everybody some time. Just basically replace all of the code inside pong.gd with what I put into the chat box. And then when that's done, raise your hand and we'll move on to the next part. All right. Oh, really? Did it not all come through? Oh, let's see here. Yeah, you're right. It didn't. Apparently there is a limit on the chat, so here's part two. Thank you for bringing that up, John. That should be the entire script. And then part two that's in the chat box literally just goes on the next line down and continues as normal. It's double indented like the line above it. Once we've done this, we're going to set it up so that we can start controlling the panels. You can just use the tab key in order to indent. So like for instance, I'm sitting here and I'm like, oh, this is not indented enough. Just hit tab. And you should see where it was. There are like a couple little arrows pointing to the side. That's how you know you've got another indentation. No problem. So yeah, the first half of this class is basically me undoing the mistake that I made um, in lesson one, but from here on out it'll be working. Yay! We'll probably at least get it done by the end of today, and then we can spend Monday customizing it with whatever you want. And we'll go over that Monday too. I'll help you guys out with that. Give you some ideas as to what you can do, that kind of thing. All right, well, got just about every hand up. Yeah, so let's go ahead and we'll get started on the movement portion because that's also going to be, it's kind of important. So as it stands right now, what we're going to make is we're going to make a two-player Pong game, and both players can play on the same, or both players play on the same keyboard. So you'll be able to, invite a friend over and be like, hey, you want to play Pong, man? And they're going to be like, Pong, and you're like, yeah, I made it. And they're going to be like, whoa! And you can play against them in Pong and totally demolish them. But anyway, I'm going to go up here to Scene, and then to Project Settings. Do you remember this window? This is where we set up the main scene and also the viewport size. We'll go ahead and click on that. And as you can see, maybe this will help to jar your memory. We've set up the Pong scene as the main scene so that it starts up whenever we start up the game. And then under display, we set up the, where is it? Yeah, there we go, 640 by 400. So it's got the size and everything like that. And if you could spend some time poking around in this too and see all the different kinds of stuff that there is there, which can be pretty useful for larger projects or more involved ones. Um, in order to customize your project, like if you wanted to, you could turn some of this stuff off in physics if your game doesn't have a physics engine so that it runs faster on people's computers or whatever. Um, uh, Modify the way that it utilizes memory in the computer. That's all, personal stuff, personalized stuff. However, you'll notice that there are some tabs up here: General, Input Map, Localization, Auto Load. Localization obviously is for translation tables, so you can port your game into other languages just by taking, like let's say you have a pretty text-heavy game. Well, you can put all of the text into a separate file that the game then draws from in order to put text on the screen, put your story on the screen. Well, if you find some nice people that can do some translation for you, they can make their own versions in their own languages of those text files that are just organized exactly the same way. And all your game does is it just draws from those text files. So they click, Deutsch at the beginning, or Francois, I guess, or Espanol or whatever, and it just draws from the appropriate file. And with a lot less effort on your part, suddenly your game is in 4 different languages. That kind of thing. Of course, if you do all the translations yourself, then it's going to be a lot more work, but regardless. Autoload is useful for bringing in single instances of a class. Maybe there's a scene you want to use throughout the entire game. It represents, like how you control the character or something like that. Because you can make scenes that don't actually like represent levels. They can just be more abstract. So you could theoretically make a scene that contains all the methods to control a character and make them move around and things like that. So it's not built into the script for the character, and then you can use the script for the character to do other stuff like animations and things. But, presumably you'd want the player to be able to control their character at all points during the game. So you'd want to make sure that that scene that has the character controls is always loaded. So you can have like an auto load, which would create a single instance of that scene in the background at all times, so that you can draw from it in your scripting and basically rely on the fact that it's always going to be there. However, we're interested in input map. Input map allows us to add more controls to our game. So as you can see, we've got UI accept and UI select and UI cancel and blah, blah, blah. All of these sort of built-in UI controls. So if you ever, are able to use like the arrow keys to select different options on a UI and hit enter, you pause a game and you can move the stick on the controller up or down to select like resume or options or quit the main menu, or just as an example. That's what this is referring to. Any user interface elements. Controls are hard baked into any new Godot game, but what we're going to do is we're going to create a few actions of our own. So up here, under action, there's this blank text box. And we can give new actions a name and then add them. So that's what I'm going to do. I'm going to go left paddle up. As you can see, I separated it with underscores, so it's left underscore paddle underscore up. I'm going to click add. And as you can see, it appeared down here at the bottom. I'm going to do left paddle right, again with underscores. Or, sorry, down, not right. Good Lord. Left paddle down. And then we're going to have right paddle up and right paddle down. So now we've got 4 new control elements that didn't exist there before. Left paddle up and left paddle down, and right paddle up and right paddle down. As you might imagine, these are going to be our keyboard controls in order to make the individual paddles move up or down. Now these actions exist. We can put them into the code and have them do things. But as it stands right now, we don't have any representation of, like, we don't have any keys representing these actions on the keyboard or on a mouse or on a joystick or a gamepad or anything like that. So let's go ahead and add that as well. As you can see next to these individual entries, there's also a plus sign and a garbage can next to them. And you can actually see that it's next to the individual key bindings as well. A garbage can will remove anything. It'll trash it. So we can remove an action by clicking the garbage can next to it. We can remove a key binding by clicking the garbage can next to it. The plus sign allows you to add a new key binding to it. So that's what we're going to do here. Under left paddle up and left paddle down, we're going to add some new key bindings. Now the left paddle obviously is the one on the left, so we're going to want to control it with the left hand side of the keyboard. So I'm going to press the plus button next to left paddle up. As you can see, I get a little menu here: key, joy button, joy axis, and mouse button. I'm going to select key, and it's going to ask me to press a key on the keyboard. I'm going to hit A, just as in the letter A, and I'm going to hit OK. So now we can move the left paddle up. Well, the left paddle up action is bound to A on the keyboard. Let's do it with left paddle down and make that Z. So A and Z are bound to left paddle up and down. Now for the right paddle, we want to use the right hand side of the keyboard, so we're going to use the arrow keys. So for right paddle up, that's going to be the up arrow on the keyboard, and as you can see, it just says up. And for the downward motion on the right paddle, it's going to be the down key on the keyboard. A, Z, up and down. Pretty straightforward, right? Like, you know, that's not too crazy. This is all just sort of our way of, you know, personal preference, finding the most efficient way to map these keys to the keyboard. So we've got left paddle up, left paddle down, right paddle up, and right paddle down. Excellent. Let's close that. So now that we've mapped those keys, we have to tie those keys to actions in the game. Now thankfully there's a shorthand. Because we added it as an action, there's actually a built-in sort of feature in the Godot engine in order to access those actions in the coding. So we can utilize that on the coding end in order to add movement to the paddles. Now, let's add it at the end here. So I have it above the set position for the ball, but below the reset when it hits the left or right side of the screen. So I'm going to add a couple of things. Get node left paddle dot get underscore POS parentheses. Based on what we've seen so far, what does this do? Just this line right here. Or what do you think it does? It gets information from left paddle. Yeah, exactly. Any specific information? The position. Yeah, that's what POS is short for, is the position. So we're getting the left paddle node and we're putting it into memory. Well, basically we're accessing the left paddle node's memory, and then we're retrieving the position from it. Now, is there anything missing from this line? Maybe something we might want to do with that information? What have we generally been doing with, excuse me, all of the information that we've been using in the code so far? Like the very first thing we do. What did we do with the ball position? What did we do with the screen size? What did we do with, the paddle sizes? It was like the very first thing we did. Well, we put it into memory, did we not? We put it into a variable. That's always been kind of like our MO is to, yeah, exactly. We put it into a variable. So we're going to create a variable called left position, and we're going to set it equal to this value. So now left position is going to contain the position information of the left paddle. And then we'll also, at the end here, do that. Now, this one's probably pretty straightforward after we're going through this. What do you think is going on here? Well, we're setting the position, which obviously means that there's probably some information missing because we aren't actually moving the paddles at all. All we're doing is we're taking the information and then storing it in a variable and then putting it right back where it was, or putting a copy of it right back where it already is. So I'm going to go ahead and do the same thing for the right paddle. So get node right paddle dot set position right position, and where right position is get node right paddle dot get position. Now we're going to stick some stuff in the middle here, in between these two commands for both of the paddles. We're going to include an if statement. Hey, actually, I believe a couple of if statements, if my memory serves me. Yeah. So we're going to say, yeah, there's going to be two if statements for each paddle. So I'm going to say if left position is greater than 0 and here we go, input dot is action pressed left paddle up. So what we're saying here is if, hold on, left position dot y, if the y coordinate, the y part of the left position, so the position of the left paddle, excuse me, the blue one, if that is less than 0, and remember that this is 0 right here, So if it's anywhere basically lower than the top of the screen, and somebody told it to move up, then go ahead and move it up. Because obviously we're not going to have it move off the screen, right? So what we need to check against is we need to check against and make sure it's not up against the top already and they're trying to move it up. So that's exactly what we've got going on here. If left position dot y is greater than 0 and input dot is action pressed, left paddle up, then we're going to left position minus equals pad speed times delta. Remember, pad speed is our constant speed of the paddles, and then delta is from our process function, so we can ensure that the paddles are going to move at the same speed regardless of how fast the computer goes. Now the minus is because we want the paddle to move up, right? And remember that the y decreases on a computer screen as we move up. So if we subtract that value, this should, left position dot y, excuse me, this should move the paddle upwards. So now we're going to say if left position dot y is less than screen size dot y and input dot is action pressed left paddle down. So we're doing exactly the opposite here. If it's not at the bottom of the screen, if the left position dot y is greater than the screen size dot y, and input dot is action pressed is down, then we're going to say left position dot y plus equals pad speed times delta, which should move the paddle downwards. Crazy as it might seem, that's all we need in order to get the left paddle moving. It's just this set of instructions right here. What we're saying is get the position of the left paddle, update that position if the user is pressing either the up or down, and then send that position back to the paddle. So now, if I were to go ahead and hit play, I can use the A and Z keys to move the paddle up and down. Pretty snazzy, right? So let's go ahead and do the same thing with the right paddle. Remember, we've got two if statements. And they're going to be if right position dot y is greater than 0 and input dot is action pressed is the right paddle up. Then we're going to say right position dot y minus equals pad speed times delta. So this is literally the same thing that we have up here. It's just any instance of left is replaced with the word right. So let's do that again. If right position dot y is greater than screen size dot y and input dot is action pressed is right paddle down, then right position dot y plus equals pad speed times delta. And then we set the position of the right node. right paddle, excuse me. So when I run it again, I can now move both paddles. I can actually have a spirited game of Pong between me and myself. And we can also see that the ball is starting to move a little bit faster with each hit. We can actually see this now because, you know, we can hit the ball more than once. This is quite the rousing game of Pong. Now, show of hands, if you were able to get that information down and get your Pong up and running. All right, I've got one hand. Does anybody need to review the code again, or? We've actually gotten to a point where the ball is moving too fast to be able to be hit by one of the paddles. Oops, too far. So if you've gotten this all down, well then congratulations, you've got a working Pong game. It's got some things that can be fixed and improved upon though. And that's something I'm going to challenge you guys to think about for Monday. Because I want to spend some time on Monday sort of customizing these and making these your own. And there is a lot you can do. You can add visual effects to the game. You can add a score. You can add, you know, some sort of simple kind of AI to the right side paddle if you want to. You can add, or the left side paddle, depending upon which one you prefer to play as. You can add like a menu screen, any of this stuff. Maybe the game resets, the score resets after a certain value, like first person to 3 wins or something like that. Who knows? However, what I want you guys to do is I want you guys to think about what you can add to the game or fix if there's something you don't like about it, and bring it back as a suggestion for Monday. And we can spend Monday implementing these in the Pong game. So this also means if you're curious about doing something with a Pong or with a game in general, we can sort of break apart how to approach a question like that or a challenge like that. Like how would you add an AI element to one of the paddles? Or how would you make it so that the ball explodes whenever it's hit, or whatever. The beauty of it is it's actually pretty easy to implement stuff in order to make a um, a game more your own. Here, let me put this into the chat box again in two parts. There you go. That's our code. But the beauty of it is there's a lot you can do to make things sort of more visually eye-catching. For example, um, this is something I've been working on and I actually spent Monday night after we did class just sort of messing around with this. But all it is just, it's more like a toy than anything else right now. But it gives me the ability, it's also got really terrible music on it. I just have like a little ship right now that faces the cursor and can move relative to it. So, in case you have ever played like a twin stick shooter or something like that, it's got the same kind of controls but on a mouse and a keyboard. And then if I ever move forward, there's a little particle effect, like engines, that fade to blue and then fade away. Or fade from blue to white and then fade away. So and this took me maybe an hour. So it's totally possible for you guys to very rapidly, prototype and customize games and stuff like that in Godot. So that's what we're going to spend Monday doing. At any rate, I'm going to close this down now and get rid of that music. That's what we're going to spend Monday doing. We're just sort of spend time making it your own. Now, let's see here. Since it's 7:55, I'm going to go ahead and do the poll questions, and then we'll do questions about anything, today, and then we'll break for the weekend. Again, provided you don't have any sort of questions, we'll break for the weekend, and then we'll meet up again on Monday. So, first question incoming.